So my name is Ted Chen. I'm from California. So my life is not as exciting as Steven's. So I don't have guitar. I don't have equipment. The last time I had equipment was about 10 years ago. And then I failed this thing called an ESD test. Each year you have to pass the ESD test, and then you have lab access. Since I failed the test, so it took my lab access privilege away. So I no longer have any equipment. So I live in Redwood City. We just bought a home about a month ago. The reason I picked Redwood City is Palo Alto is a very expensive town. That's where I work. And it's close to work, about 15 minutes away. But anyway, so sorry for the rambling. I didn't make the flight. It was about 12 hours delay in San Francisco. There was a computer problem. And then after replacing the computer, then the captain said, we exceeding the FAA working regulations. They cannot exceed certain number of hours. So we had to go back to the gate. So I waited there for 12 hours. So we finally made it at midnight in Seoul here. So anyway, I'm glad to be here. And it's an honor to be the guest of SK Telecom to present to you on OpenSwitch and open networking. Okay. So I was an engineer. So I liked this Venn diagram. So I just want to point out that in this disaggregated market, and there are two things that's important. The first thing is disaggregation. So you have separation of software and hardware. And the second piece, I think is equally important, as you hear from Steve talk about this open source, Linux. And then OpenSwitch is also a complete open sourced operating system. And more importantly, and there's a community behind it. As you see, the community is very important because you want to have a community and the participation and this thing to grow. So I'll talk a little bit more about why we care about open source and why community bring the value to many customers and markets in the world. Okay, so there's two pieces, open source and disaggregation, and that OpenSwitch is right, fits in both categories. This is the picture shows on the left is what we typically see the traditional switch, what it looks like in terms of the component of the structures, from the merchant silicons, chips, ASICs, to the system, to the operating system, protocol, and application. As you can see, everything just kind of so I would say, craftsmanship built to just fit in that way. You don't have choice to play with it. Now, on the left side, and this is a different way of building a system in the open world, and you're starting from where you have the merchant silicons with Broadcom, Cavium, and Mellanox. I just saw the Mellanox folks there. And by the way, OpenSwitch is running on the latest 100 gig Spectrum chipset. I was at the HPE Discover 2 weeks ago in Las Vegas. So the Mellanox folks had a huge booth there next to Arista, and where the OpenSwitch is running on that Spectrum chipset. I took a photo of it, but on my phone, I cannot show this on the session there. But I would love to talk about the capability of the Spectrum chipsets as well as others. And because there are others in that place, I'll talk a little bit more. And then you going above here, that what I would call the system here, because that's where the white box vendors doing of putting the different kind of chipsets in a different system design. So HPE providing a bright box is based on the Acton, but there are others as well. Now, as far as the OpenSwitch concerned, that we're working with many different platform vendors. So today, because of the effort of the community, actually one of the potential customer they are working on that's LinkedIn, and they actually pour themselves onto Celestica, Seastone platform. That's a 100 gig platform, all by one of the partner here. So I'll talk a little bit more on that effort as well. And then you go up there, that's where sort of a choice option system come to pictures. You can open source Linux, you can do OpenSwitch, you can do Cumulus and PK, and this all via this thing called Oni bootloader. Because Oni bootloader allows you to choose the operating system. And then you can have Open Daylight Controller, OpenStack, private cloud orchestration, and all the open source go on. Okay, so on this side is what I call the open system here. Okay. Okay, so we're just showing the picture on the component. So on a high level, you say, if I want to build a open source data center, what are the components there? We talk about quite a bit on the OCP. This is the physical layer. So the way I think about testing it this way, it's open source hardware, okay? And that's OCP. And then you have open source software. And for OpenSwitch, it is a community behind it, openswitch.net. And then on the server side, you have virtual switch, that's OVS. Now, these two guys have a close relationship between these because this came from that. So if you look at, say, OpenSwitch architectures, we just pull everything apart. What you see underneath there, there's a database in there, okay, and a schema, and then OVSDB management protocol, RESTful API, okay. So this has a common thing there. What we did differently on the OpenSwitch was that there's a quite bit of engineering work to build this thing together such that this OpenSwitch as operating system, it doesn't look like a whole bunch of many Linux projects putting together in the last 20 years, but rather it's I would say, Italian craftsmanship, putting things together in a nice, polished way. It's sort of what I call it, the open source version of the Arista EOS type of thing, because it's based on common type of structure and philosophy to say, we want to keep all the data in database, okay, in a non-perishable way, okay. I will talk a little bit more on what it means of imperative configuration vis-a-vis the declarative configuration, and the OpenSwitch took the approach of declarative configuration, and there's tons of benefit with that, and also along the way, because you're doing database approach, and every communication coming through the OSBDB to the database, and then so the high availability make the things a lot easy because the database is always there, okay? And then the application can die, can go away, and can be restarted, and it's easy to recover the state from the database. Then for each application thread, keep its own database infrastructure, and that's where the software complication came in. So think about the fundamental way, it's a very nice, elegant architecture there, okay? So that's that. So we talk about, I already talk about the declarative configurations, okay? And then enhance the stability, resiliency, and fault tolerance, isolation with that type of architecture, okay? It's entirely possible with a community effort down the road than with a single CPU architecture. So I'm sure lots of folks here on this floor are very familiar with HA. And you have the active RP and the backup RP, and if the active go away, the backup take over, and all via the ISSU and the synchronization between two states, between two line cards, right? And with that database approach, it's entirely possible on a single CPU system to achieve HA, okay? Just think about it. And I believe this is an exercise, and I very much hope somebody will pick on this thing and do that implementation, okay? So that's that piece. The other two pieces is really about the development and the testing, okay? Is using this, I was an engineer before. I came from the waterfall model. So as you know, the waterfall from the requirement, the specification, development, testing take a long cycle, okay? Obviously, this is not today's world in terms of open source. It's all about DevOps, NetOps, and agile development, and how quickly you go from the inception, from the business requirement translate to code and to the implementation and testing. So all those things can happen on your laptop. And this is a powerful tool called a Docker container, okay? So I just leave it like that. It's a very powerful tool. It can be a friend, okay? I think this is an important piece. People care, say, Why put open source? Can open source make money? Because open source is free. So there's all kind of comment. So I think that this is important kind of hear so many things about the Linux, of all different components. Let's just step back, look and say, okay, so open source is, I won't say cheap, it's less expensive, right? But it saves you money. But really you look and say, is this better, right? People want to buy cheap things, but you say the cheap thing is not as good as the other ones, okay? So my argument here is that because it's open source, because we're taking the agile development process where you have a community and the component member of the community share the requirement and jump into the code development. So this, I would say, from the requirement to the code to the deployment, that time has collapsed from perhaps during my day as an engineer about 2 years, because I was an engineer in the networking industry, and easily during my day of engineering days, they take about 2 years. Start writing code to qualify to see in the telco, such as SK Telecom. But now with open source, it's much, much shorter. It's clapping down to perhaps as short as 3 to 4 months. That's where you see the code that's getting there. So in a short sentence, that business requirement gets into the deployment, the time gets collapsing down. And there's a tremendous value there because time's money. So if you think about the money means time to deployment, this is much shorter, okay? So that's the business aspect of agile development that's so powerful there, okay? The other piece I would say, the quality. Because it used to be the way you develop the code, an engineer responds for a certain section of the code, and you write it here, okay? Now with the community, you can imagine this whole group of people, audience here, participate in OpenSwitch development. And then it's no longer become issue say, I own the OSPF Quagga code there, but rather there's a lot of people look at that. So I'm using quote this, the guy, Linus Torvalds, who the father of Linux, and he once said, give enough sets of eye, all bugs become shallow. So I think that it's a paradigm shift, it's a methodology shift. We are coming to a new world that's an open source world, okay? I talk about business agility, and last piece is the key piece difference that when you look at OpenStack, okay? There's a community behind it. OpenSwitch is a community behind it. The key thing have community instead of have vendor to control the open source. It's all open source, but I'm saying open source is different. Have the community behind it's hugely important. As you know, that we, HP Enterprise, along with a few other partners, that including the Cosmos, into Arista, Intel, Broadcom, and others, started OpenSwitch. And since then, this OpenSwitch become a Linux Foundation project, so official Linux Foundation taking over that. And then there are other partners, the charter members in the effort there. You look at Cavians, Mellanox, they are a huge part of effort in there. So as you can see, the risk for business to adopt the open source project become a lot less because you are less depending on one or two vendors who control that. Whether that vendor is in business or not, it's much harder to say Mr. William Hugh and David Packard started this HP in 1937 in a garage in Menlo Park at the beginning of Silicon Valley, and it's still live and kicking today. But things going through phases, okay? You look at the IT industry in the last 20 years, and that industry littered with dead body, okay? And what was giant yesterday, not necessarily giant tomorrow. So the key thing is that with the foundation, with the community backing in there, that there's some safety there in terms of adopting open source. That's the other key piece of open source, okay? Ansible, if you care about server and networking convergence, you want quick way to convergence to provision things together, and Ansible is an important tool and a friend there, okay? Of course, for those of you know that Ansible was bought by Red Hat, so there's a Red Hat entity there. And there was a collaboration on open source effort there between the OpenSwitch community and the ANSIBLE team, and they put this thing together quickly. What I didn't have the chance to show, I actually put a different deck in there. It was talk about, maybe just verbally describe that in terms of on the OpenSwitch.net, there's a GitHub on the Ansible playbook, and in there are different roles in there where we have the engineer work on the BGP role and the switch role, and use those template and there was a YAML file and it was variably defined, for example, interface, ports, AS number if you choose to use eBGP to build a three-stage cross fabric, and those things there. Now with that, you can really converge, use the same tool to converge not only the server, configure the server, but also the networking gear as well, and quickly build a three-stage cross fabric with BGP, for example. So the playbook are there. Now, certainly it's not complete, and that's part of the beauty of the GitHub there, that participate in the effort there and allows you to quickly populate and contribute with new playbook and etc. with different roles, for example. So that's the Ansible effort with OpenSwitch, okay? So these are just a whole bunch of, I would say, northbound interface. The one in the middle is sort of command line interface. So I came from Cisco background, and those things just look like so intuitive to me. You know, for example, I can just pick up things like, say, you know, show IP interface, show BGP routes, and those things are there. Okay. So if you're familiar with Cisco iOS, and those are very close to that. And to the left is the REST API. Okay, because it's all based on database and schema, and RESTful API, OVSDB management protocol. So all those things are there, and that's a part of the beauty of declarative configuration. It's not about how to configure this thing, but rather tell the switch what you want to do, and this thing taken care of by itself. Okay, in a very precise and persistent manner in terms of the provision. Okay, now. On this side, here's GUI. So why you care about GUI? Because that part of the thing is about, we want to understand what's going on in the switch. And this thing talk about how the buffer is being utilized. So I'll talk a little bit about network telemetry and how do we do analytics and how the OpenSwitch support that, okay? So that's the last piece. Yeah, okay, so this is the slide talk about the telemetry visibility analytics. So you can buy as many switches you want and build a huge gigantic network, but we all know that's not efficient. So the ideal way is that use as much less equipment as you can without getting into trouble, right? And the key thing is understand how you're using the system, right? Even if you want to tell your boss, say, you know, I'm running out of ports, I want to buy another switch, buy another rack, buy 10 rack, 100 rack, you still need to show the analytics, that how is the existing equipment being used. So the key part is got to know what's going on in the network, how's it being used in good or bad manner, okay? And the effort of collecting the data from the remote endpoint and then transmit across, that's what we call telemetry, right? But that's not enough, that just have the data is not enough, so you have to do analytic part of it. So that's a second piece, okay? So this piece. And then you need to complete the loopback active mechanism, say, okay, now I have understand what's going on there, and what do you do about that? For example, you have microburst situation, then what do you do about it? So, well, we're going to do ECMP rehashing and complete the cycle there, and that's what I call network telemetry, visibility, and analytics. Okay, now, enough the babbling on my side about this, and what I want to talk about is, this is not my slide. Actually, I was in Open Network User Group in Mountain View in April. Any one of you there, perhaps? Anyway, so this is our partner Broadcom presentation. This is the one of the slide. Quite busy slide. There's lots of things. They did lots of contribution to OpenSwitch. Let me just talk about since I was talking about network analytics. So this is the broad view technology. So as you know, that Broadview is an open source network telemetry analytic tool. And there's a Broadview daemon. Because the open architecture of the OpenSwitch, there's actually a Broadview daemon running on OpenSwitch and collecting stats, okay? And via the Broadview API, and they send the data through to the open data controlling applications, okay? So there's a whole ecosystem that based on the Broadview. So that's one of the contribution there. And for things like a little bit more granularity in terms of buffer utilization, because things can happen very quickly, and you want to just look at traditional way, like look at interface stat. It may not be sufficient. You want to look at, say, okay, I set a watermark, and the very fine granularity there. Has that buffer utilization crossing the threshold? When it crosses, can you tell me that? All those things, the modern way of looking at the detail of the networks in a very fine granularity, this happen in the network telemetry. So the open source version is in the Broadview. So that's in part of that, okay? Other piece that for those who care about NFV solution, you want to use translate the business policy via the open data controller to open flow firewall policy, pushing onto the switch. And this Broadcom implement the OFDPA. So this is certainly not a completed project. There's a current ongoing work with OpenSwitch on the collaboration with the Broadcom in OFDPA, okay? And then, of course, the OpenSL, this the open source version of the API sits above the Broadcom SDK, okay, the closed source SDK. So that's that piece. I have a little more share on the other part of it, what the other merchant silicon is doing using different API. So the good news is that via the OpenSwitch, the open source, you open up those API to different chipsets, allow them to take advantage of the key capability of the merchant silicon chips, okay? Yeah, that's all I'll talk about on this piece. Okay, so Mike McKeown, a Stanford professor, the guy who invented OpenFlow. So I met him a couple months ago, and this actual slide came from him because he started the business world, and they started this company, venture capital-backed company called Barefoot Network in Silicon Valley, where they have pioneered technology called the P4 language. So the P4 language support for OpenSwitch is there. So you might say, why P4? Well, the way I look at P4 is sort of a software-defined ASICs, that's what I call it. Because now you can use a software language. The things are very close to the heart of a software engineer. You can define the pipelining of the chipset behavior, okay? Now, so with OpenSwitch, the driver support for the OpenSwitch is there, which means that you can actually testing a chip without the chip being bought up. So for those of you who are in the hardware ASIC, I'm not, but I used to sit across, when I did the other company, I sit across an ASIC developer there, and she's a lady, I've talked to her many times, say, how are you doing, and how long it takes to bring up a chip. And I can tell you that it does take a long, long time, tremendous investment to bring the chip up. So what that means is that, in a different way, OpenSwitch as an open source operating system allows you to see a new chip without chip being up, and have the ability to test the chip behavior much, much sooner. So that's another called the business agility there via a technology twist. You cannot do in any other way other than via this powerful way, building a driver using the P4 language to define the pipeline behavior there to test a new chip without ASICs being brought up. So this is darn powerful there, okay? So that's that. Okay, so in this merchant silicon world, we know Broadcom has a dominant market share, it's probably more than 70% in the data center space. But that doesn't mean the innovation stopped there. And indeed, you look at this is the slide from Cavian. That's the Cavian slides at the ONUG, and where they have this new chipset called the X-Plane. Okay, X-Plane is actually a very powerful thing. In my little world, I look and say, this data center chip is no longer a data center switch anymore. You can turn it into a router now, because guess what? It can do 2 million routes. And how do you achieve the 2 million routes in there? Because in that chipset has a very flexible way of, in terms of control the pipeline. So you can carve out what's for L2 and for L3. To me, I really care less about have arbitrary way of carve out L2, L3, other than say, heck, in a routing world, I don't have much L2 because my L2 is just my op table, right? And I have no switching table, I don't have MAC table, right? But everything is L3. And if you want to build a large L3, guess what, that's there. It has 2 million routes. And with 2 million routes, it can solve the world hunger. Because, first of all, data center interconnect, data center WAN edge, you can have that. You want to bring the full internet table for a DDoS security type solution, you can bring down to there, right? But beyond that, you can build MPLS, right? MPLS WAN, MPLS core, MPLS edge, MSE, the older term, right? Multi-service edge. All this require a large routing table with multiple VRF. Guess what? That technology is there. Of course, I'm talking about the future there, but in terms of capability, they're there. So what they did is they actually port OpenSwitch, and with a different API called a Open API XDK, okay? And this have a direct way to have access to OpenSwitch, okay? Very, very powerful. This really, I see the future of networking, how you evolve, okay? So that's that, okay? Now, Mellanox. I think I saw the folks, I just chatted briefly before the session starts. The Mellanox folks. So out of Las Vegas, again, that talked to the Mellanox folks, and they have the Spectrum switch. So Spectrum switch, it's a 100 gig switch, and it's a low latency. And if you do cut-through switching, the port-to-port latency is about 300 nanoseconds. So that's a very powerful thing. And it's beyond that, have a very nice way to control, of course, have a large buffer space than the other switch, and it also had a virtual output queuing, okay? And last but not least, that Windows Server has it. If you have a non-loss host, okay, that's how back to my engineer day about TCP behavior, okay? How do you find out that the condition is not good and you want to throw back the TCP window, right? By identify the packet gets lost in transmission, right? Well, it's against intuition. You don't want to drop the packet in this case because the host OS has the understanding behavior or keep track of IPECN, okay? So if you do IPECN, you don't want to drop the packet with the red. You want to mark the packet and let it go out. At the destination, it will turn around and flip bits so the source know, okay, my network experienced congestion. Even though I have not lost any packet there, let me throttle back. So this is a very powerful thing. And they have some of the secret sauce in there, how to control the lossless fabric in there with IPCN and by jumping the queue. So lots of innovation there. But the key thing is that you have another standard thing called a SI interface. So OpenSL and Cavian SDK, Cavian API XDK, and then the SI implementation. They use SI to interface with OpenSwitch. So that box is running 2 weeks ago in Las Vegas. I saw that, and it was really exciting news. So you can see it is a little bit beyond just the open source with Linux, whole bunch put together. It is about open API, how to quickly integrate with chip, because you can talk about open source to this, but if you don't have the chip to implement it and working model there, this is just the fantasy there, right? This is where the bring into reality, how chips being implemented with the operating system such that you can use it, okay? So that's that piece. Okay, so I talk about enough about, on a system level, the chip and the merchant silicon chip, and then the system, okay? So I want to talk about user, the end user who use data center, okay? So this is another angle, how an end user can collaborate with the open source community. So we have I'm sure that most of you, like me, I have a LinkedIn profile. So there's a company called LinkedIn, actually in Sunnyvale, California here. It's about 15 minutes away from my office. So we have quite a big collaboration with them. And they look at this and say, okay, so HP, you guys have Acton Edge Core box. Guess what? I don't like that box, okay? I want something different. And I have my eye set on C-Stone, Celestica. So why don't you pour yourself? He actually poured himself. They poured the linking engineer, poured the OpenSwitch onto C-Stone. That's Celestica. C-Stone is a code name for 100 gig platform. And they did that, okay? And along the way, they look at OpenSwitch capability. Say, okay, you're great, you have BGP clause, but guess what? In order to identify the neighbor goes away because the link flat, but BGP neighbor goes away. I want a way to figure out why this goes away because the BGP loopback is not direct connected. How do I find out if you have non-interface cut, right? Non-fiber cut scenario. Okay, so guess what? We need a BFD for BGP. And I would say, well, guys are all busy, we're doing different things. So what can you do? Well, they did it. So there was a linking engineer. I go to Palo Alto office and they say, who is that guy there? I never seen, oh, this is a linking engineer working on BFD. So I can see the collaboration in many different ways on different pieces of this thing because all doing together makes things happen sooner and each individual may get something back in terms of benefit. So that's the other piece of the benefit there, okay? So their next step is really building a 3-stage clause and go try out in their data center. They are keep on building data center. Well, the last room I heard is that is somewhere on the West Coast. They build a huge data center there as well. Okay, so that's that. I'm pretty much just close to my presentation. In the last few slides, I want to share that in terms of what the HP offering that is from the hardware perspective. The auto line was based on the Acton Edge Core product, and then PK and OpenSwitch and other NOS that's running on top of that. Quite a big portfolio there, and so that's my presentation. Any questions?
있으시면은 여기서 하셔도 되고 지금 여기 라이브 톡에 질문이 하나 올라온 게 있어서 그거 보는 동안에 질문을 받도록 하겠습니다. Maybe this one?
So what's the OpenSwitch strategy for managing plane of switch, open config support? Very good questions. Open config is something I've been talking to. Actually, I had a conversation with a Google engineer in April and ONUC. And we have a candid conversation about the value of open config. And of course that there are things, you cannot do all things at one time. It is many times it's about community effort and all commercial effort. You have a customer, you want to do something, and a vendor can jump in there. And that's sort of where we are. And I look at this thing because we're starting with the cloud service provider, and we want to converge the server networking convergence. So ANSIBLE, NetOps, DevOps tools start from there. That doesn't mean that's the end of it. And I definitely see quite a bit usefulness of open config because that solves the fundamental problem of convergence of BSS, OSS, right? You can talk about all the things. It's about Ansible, it's about Chef and Puppet, it's Netcom. Guess what? Each operating system behave different way in terms of command line interface. And you say, I have 5 equipments from 5 vendors, right? And do you want me to rewrite this OSPF 5 times, right? So OpenConfig solved that problem. So I definitely see OpenConfig is a important part of the thing. And, but it's also beyond that, because I think I just saw the demo there on the Kafka. And that Kafka really interests me, because there's quite a bit of interest in the Apache sort of open source, the message bus, for the purpose of doing provisioning as well as getting network analytics back. Because I had the example here say, okay, I use Open Daylight to send the network telemetry information to the Open Daylight and then the application there, right? But you can do the same thing with the Kafka bus, right? What if somebody would just go ahead and write the OVSDB driver for Kafka, and then you have OpenSwitch that's suddenly working with Kafka? So that's down powerful thing. So that could be another thing here that the management strategies. So I kind of just mumble on many things, and I think that perhaps I don't have a strategy. Really, the strategy is where the community takes this into that direction, what is it going to be? It's not going to be a single person to say, we should go this, we should go that. It's really about who are the community, what are the community interests, where we want to take this thing to the next steps. So I can see Kafka with OVSDB as an example, OpenConfig was another example to evolve the network management plan. Okay.
The next question is, we can consider the Open Network Linux as your competitor. We saw the previous session.
Yes. Yeah.
What do you think about the ONL?
I have lots of respect because they are all open source, right? I think in general, because open source and disaggregation open the market. And this is sort of a very fundamental shift in market, because folks want to have a less expensive equipment, but more importantly in terms of the diversity, the richness in terms of the hardware ASIC support. And that's an important piece of thing. And then the other piece is really about time to deployment. To realize that from business requirement to when you see the code and deployment, that open source get you there. Now, come down to the specific, and they are all open source. But I'm gonna say not all open source created equal, right? In my presentation, I emphasize quite a bit in terms of the community support. You don't want to have large community support because why? Because you don't want a single vendor to lock in on that. And that's number one. And then the other piece is that OpenSwitch is sort of built in a nice way of a very polished open system. You have the common look and feel, command line interface, the schema, and everything. So from that perspective, if you're familiar with Cisco iOS, you can tell I have for 10 years experience with that thing. And it comes very naturally, okay? So it's a very polished product. It's not a whole bunch of things kind of just happen to be together. You have to kind of manage that thing, the patching, etc. You do get a real open system there. So there's quite a bit of differentiation in there. I think the key thing is that they're all in the GitHub, right? And it's not what test it. It's really about you go ahead and just do it and look at it and try it and see what the differences are. Okay?
Okay. Thank you very much. 예, 이걸로 이번 세션을 마치도록 하겠습니다. 큰 박수로 인사 부탁드립니다.